Hello guys, we'll just keep on track, and this is type C for Oxford Mathematics Admission Test. So that's October 30, 2019. It's pretty fresh. Okay, let's get started. That's sort of, challenge because I've never attempted to Oxford, and this is like first time I see that, and just I try to go through and probably give my comments about the complexity level, about what I actually need to know about this. Okay, so you'll see. So let's go and type C. So the reference actually to the explained video. So instead of like 2.50, you'll have like 10 minutes explanation. That was really short, but if you want to know details, you'll see that in my video. Just watch. Okay, so we have the graph of, and we have the function yx equals to sine squared x plus sine 4x plus sine 6x and so on. So basically we consider only even powers. So even powers. Of course, it's hard to say how it goes, right? Because it's basically senseless to try to sum up to infinity, because there are endless number of terms, because the last term should have the form like sine 2n, because it's even power of x, and senseless because it's endless series. Okay, but actually if you heard the word series, you probably want to to see what sort of series. Remember, there might be a sequence, right? And specific type of sequence tells you how to find the sum for the series. This is actually what you need to do, because instead of y from x, instead of series, right, of infinite sum for the terms, it's better to see just one formula, right? That tells you, so it's better instead of f, just write sum just from x, okay? Sum of x, or, yeah, this is the way that we want to test, okay? And it's much simpler instead of infinite number of terms in the sum. All right, so we agreed that we need to recognize sort of sequence. For this reason, to see the structure, I would basically recommend to make input new variable as sine squared x equals t. So by the way, we put immediately conditions for t is more or equal to 0, right? Because t is sine squared, so sine squared never be negative, okay? And by the way, because we know that sine x is a restricted function, so absolute value is less or equal than 1, so I means -1 less or equal sine x, which is less or equal than 1. So that's why we have extra restriction for t. It's also, so from -1 to 1, in combining two conditions, we know that t should be not strictly more equal than 0 and less or equal than 1. Okay, that's our key limitations here. Okay, so let's test how it works. So y from x now, just simply in terms of t, y right in x goes t. So we'll get t plus t squared, then t cubed, then probably t to the power 4, and plus something something up to the end. So infinite number of terms. All right, what sort of sequence? Of course, that's geometric. So let's consider sequence t squared, t cubed, let's say t4. So the common ratio is obviously t, and the first term is just simply t. All right, so we marked as the ratio equals t. Okay, and now it's right time to think about analysis. Instead of like rushing ahead and trying to, pick up the formula for the sequence, we just simply need to analyze. Of course, there are infinite number of terms, right? You have several formulas for the sum of geometric sequence. But hold on. If you have a ratio, let's say more than 1, more equal than 1. If you sum them up, if you sum up the terms, you'll get definitely infinite number for sum. So it's not good, right? Because you want to have something like limited. So basically you want to have your sequence or series to be convergent, right? Instead of divergent. So that the sum should have some, finite value. Okay, we have some problem because our ratio becomes t, and due to yellow restriction, which is here, so we can say that ratio is more equal than 0 and less or equal than 1. Okay, so that's why we need to consider two cases. First, if the ratio is 1, and the second, if the ratio is strictly less than 1. So let's explore the simplest case. So if the ratio is less than 1, we definitely have the formula sum up to infinity, and this sequence is convergent. So this is convergent type. So converge. So remember the formula, s up to infinity is just simply u1 1 minus r. Alright, so let's plug our variables. So instead of u1 we just mark t. So we write s up to infinity simply t, right, over 1 minus, and r is just simply t. And we understand that in this case t or r, as was previously, should be strictly less than 1. So t basically is not equal to 1 and should be within 0. 0 is okay, but less than 1. So okay, go back and remember that t is actually sine squared x. Let's put it back and see how it works. So sum up to infinity is the function of x now. Just come back and put sine squared instead of t whenever t stays. So we'll get sine squared x over 1 minus sine squared x. And we'll finally get sine squared x over cosine squared x. Yes, we just use trigonometric identity, sine squared x plus cosine squared x. Alright, so we'll get the tangent squared x. And just remember how tangent squared, or just simply tangent, behaves itself. So we know that for some reason 1 minus sine squared is not to be, basically 1 minus sine squared is not to be able to have the value of 0. So cosine x is not equal to 0. So actually we can stop here, right? So we can stop here and try to see, okay, we have values that are excluded in terms of x if we want to build our function. All right, so cosine x, let's just remember the unit circle. It's not like pure circle, sorry. I don't have a circle tool here. Okay, something like this. So this is the unit circle. So cosine x might be equal, when you have 90 degrees, minus 90, or within, 2 pi n. So actually x is not able to take the values plus minus 90 degrees plus 2 pi n. In terms of 2 pi, I'll better to use 360 because we consider degrees instead of radians. All right, so we got that. Okay, and let's analyze our choice, right? So if you have a look to A, that's definitely not the case, because now it's right time to remember how tangent works. So from 90 into negative 90, it works like when x is 0, that's okay, so sine x is 0, and it touches the origin, right? And then it goes sort of outwards and branches up, something like this. So it cannot take 90 degrees at all, so your tangent should go like this. Even the tangent squared, that's okay. Simply it gets a bit narrow, the normal tangent. I hope okay, because thrice faster. Okay, so, and that's actually what agreed to our case. So we can simply try to consider the following options. So either B or C. But in both cases, so B and C, you see that what's happening at 90 and negative 90. So these values are allowable according to the graph. So B and C also eliminated. So A is apparently eliminated because it doesn't touch the origin. However, B and C also eliminated. So we stay with D, and still we have E as an option. Okay, right now is at least you have 50% probability to guess, but normally you don't need to guess. All right, we'll go next. So what happens next after 90 degrees? What will happen? You have tangent square, and tangent square is always positive or at least 0. So that's why option E is also cancelled. You don't need to be able to graph the full, version of the graph. Just try to think analytically and try to work on elimination methods. In this case, you can work faster. So, okay, so we finally arrived to tangent squared x, and because it's positive function or 0 function somewhere, so we can say that the rest part of the graph should go like this and like this. And again, one key point, so 180, that's okay. This point, cosine x equals -1, but because sort of squared, you'll have just, sine to be 0, and you'll have tangent to be 0 as well, okay? So 180 and -180 values are allowable. Okay, so that was type C for Oxford Mathematics admission test. Hope you enjoy, guys, for detailed explanation. If something is not clear, just give the comments, drop the comments, and so I'll try to give the feedback immediately. So about like those who want to keep with me and just keep on track in math science, just don't forget to subscribe, push the bell button, and actually you'll be in touch with me. So thank you.